the second part of the method of variation of parameters is actually two very clever tricks. The first very clever trick is that we are going to look for a particular solution of the non-homogeneous differential equation in the following form. We take the general solution of the homogeneous equation and we replace these two constants with functions of t. So it is u1 of t times t minus 3t plus u2 of t times e to the minus 3t. All right, so they were constants, and now they, instead of being constants, they vary, which is why the method is called variation of parameters. So that's the first clever trick. Now, the next thing that we should do is we need to find the values of u1 and u2 such that if we substitute it to the differential equation, then we get a true equality. Well, the equation contains y prime and y double prime, so let's find y prime. So what is y prime? Y prime is going to be y1 prime times t e to the minus 3t. Now I'm differentiating the first term plus u1 times you know what, I'll just try it, t times e to the minus 3t prime without actually computing it. But then it is more convenient to continue on the next line. You will see why in a second. So it is going to be plus u2 prime times e to the minus 3t plus u2 times e to the minus 3t prime. Well, and here comes the second very clever trick. You have to think a little bit ahead. Now we could continue and we could compute y double prime, and then we could substitute it to this differential equation, and then we could try to solve for y1 and y2. But then we would have one equation with two unknowns, u1 and u2. So, which usually means two things. First, one equation with two unknowns, it has infinitely many solutions, and we do not need infinitely many. We are just looking for one particular solution of this differential equation. And second, there is no general method to solve one equation with two unknowns. All methods to solve equations, they are about one equation, one unknown, or maybe two equations, two unknowns. So one equation, two unknowns, it doesn't really make our things easier. But if we had two equations with two unknowns, then it would make things easier. Well, but we only have one equation. So if we want to have two equations with two unknowns, where do we find another equation? And the trick here is just to invent the second equation with the logic that we want to make our life simpler. So we want to simplify calculations. So we want to invent a second equation such that our calculations become simpler. And at the same time, it will give us two equations with two unknowns, which is doable. So the natural trick to do is, so imagine that if we differentiate this again, then these two terms are going to give us some u1 double prime and u2 double prime. And of course, it's better not to have that. So we are going to require that the sum of these two terms is 0. That's the second clever trick. So the second clever trick is to, additionally to the first equation, we are going to request that u1 prime times t e to the minus 3t plus u2 prime times e to the minus 3t is 0. Right, so this comes from a clever trick. Well, and if this is 0, it means that this part disappears. And now y double prime is much simpler, right? So y double prime, we just need to differentiate this again. So then we are going to have u1 prime times t e to the minus 3t prime plus u1 times t e to the minus 3t double prime plus u2 prime e to the minus 3t prime and plus u2 e to the minus 3t double prime.